So I want to look at this exponential equation in Desmos, and I'm going to click on this button right here that says All. Now, one student asked me yesterday, what happens if the b is equal to 0? And if the b is equal to 0, do you see that it makes an exact straight line? It is not exponential, because 1 raised to the first power is 1, and 1 raised to the second power is 1, and 1 raised to the third power. It doesn't matter what the power is, it's still equal to 1. And also we looked at it yesterday, and we don't see any exponential graph if this b is equal to 0, equal to a negative number. So I'm going to change this b to 0 because we don't care if it's a negative number. Now, if the b number is less than 1, do you see the decay graph? If the b number is bigger than 1, do you see the growth graph? And do you see that the bigger the b is, the more this goes up, the steeper it is? But do you notice that this is not at the x-axis this time? If I change this to 0, this is at the x-axis. But the whole graph can move up or down depending on what this number is down here. This number can move up or down. Do you see that this looks like it touches the line y equals -3? I'm going to change this to a dotted line. Do you see that it looks like my red graph touches this line right here? But it really doesn't. If I change my settings, we can see that it's getting closer and closer and closer to that line, but it's not ever actually touching that line. When you get closer and closer and closer to a line without ever actually touching that line, that is called an asymptote. This line right here is an asymptote. The graph is getting closer and closer and closer to that line, but it's never actually touching it. The line is getting closer and closer and closer to this line, but it's never actually touching it. What's this line called? This line here is called an asymptote. And most of the time when I make a graph, I put the asymptote in with a dotted line to show where the asymptote is. So, on your notes, the first thing that we need is the definition of an asymptote. Okay, here's our first example in our notes. Now, this is an exponential graph. Do you see the exponential curve? Is this graph a growth or a decay? As I go across the graph from left to right, do you see it going up? So that makes this a growth exponential. Now, I clipped this picture out of Desmos. Desmos does not put arrows on the end, but if it's going all the way to the edge of the graph, we can assume that it's supposed to have arrows on the end. Because it's supposed to have arrows on the end, that's why the domain is all real numbers. Before we do the range, I'm going to do the asymptote. This dotted line is the asymptote. As we go farther and farther out this way, the exponential would get closer and closer to this asymptote line. Well, where is this asymptote line? It is a horizontal line with zero slope. The equation for this horizontal line is y equals -5. Do you see that this purple line, all of this purple line is above the asymptote? So that means the range is above, greater than, the asymptote at -5. Y is greater than -5 is the range. Not or equal to, because by definition of an asymptote, it's going to get closer and closer and closer to that asymptote, but it's never going to touch it. Another key feature for our graph is the y-intercept. This is the y-axis, this is the y-intercept. Next example, as I go across the graph from left to right, does this grow or decay? This is a decay exponential. It does not have arrows on the end, but the arrows on the end are implied by going all the way to the edge of the graph. Because it should have arrows on the end, the domain is all real numbers. This dotted line is the asymptote. The asymptote is at -2. All of this purple line is above the asymptote. So y is greater than -2 is the range. All of this exponential is above the asymptote. The y-intercept is 0, +2. Those are the key features that we are going to need to be able to determine from a graph of an exponential: the domain, the range, the y-intercept, and the asymptote. Here is another exponential. As I go across the graph from left to right, it goes up. So is it growth or decay? The asymptote represented by the dotted line is at 1, y equals 1. All of the purple graph is above that asymptote. Above means greater than. Y is greater than the asymptote at 1. Is it pretty easy to find the y-intercept? Do you see that compared to the graphs that we've just been looking at, this one's flipped upside down? And because it's flipped upside down, it's a little bit hard to tell whether it's a growth or decay. It was a graph like this that was flipped upside down, so this is a reflection of a growth equation, but I'm not going to label it either growth or decay, because on reflections, where it's been turned upside down, that's kind of hard to tell sometimes. But Is it easy to tell where the asymptote is? The asymptote is at y equals -2 is the asymptote. Over here, it's going to get closer and closer and closer to this asymptote. But this time, is this graph above the asymptote or below the asymptote? It's below the asymptote, so this range is y less than -2. Because it's been flipped upside down, this is less than the asymptote, and so we have a less than sign in there. The y-intercept is at -5, 0, -5. Can you take an exponential graph, label the domain, range, y-intercept, and asymptote?